You're welcome to another exciting moment. Um, Here we're going to look at a question that says the source of sound or frequency 660 hertz emits wave of wavelength 1200 millimeter in air at 40 degrees Celsius. What is the velocity of the sound in air at this temperature? And what will be the wavelength of the sound from the source in air at 0 degrees Celsius? So here we're going to, let's quickly look at the work we have here. So that the frequency we have here, our frequency is 660 hertz, and we have our the wavelength. The wavelength is, then we can convert it to meter. We have divided by 1000, that will give us 1.2 meter. Yes, we're going to solve the first question, so that what will be the wave velocity of sound of that. So we'll do that. So we know that velocity is always frequency times lambda. So when we do that, frequency times lambda, then that will mean 660 times 1.8, not 1.2. 1.2 will give us 792 meter per second. This is the velocity. So now we've done the first question here. Now the second one we have, the second one said that what will be the wavelength of sound from this source in air at 0 degrees Celsius. So in this case, what we're going to, you remember that according to Laplace correction, it is meant to understand that velocity is directly proportional to temperature T at Kelvin. That is, velocity is directly proportional to the square root of temperature at Kelvin. That is absolute temperature. So in this case now, before we can get the temperature, the velocity, the wavelength, we need to get the velocity at 0. When we get the velocity at 0, then we'll be able to get the wavelength. So in this case now, we have a temperature again here. This temperature is 40 degrees, so I kind of going to compare them in order to get the actual thing that we are required to find. So with this relationship, the next thing we are going to do now, we're going to compare the two velocities that we have here. From here we can get, because since it's directly proportional to the square root, it means that velocity at the temperature over velocity at 0 will give us square root of the temperature at this time, and then square root of the what of the 0 over square root of the 0. So in this case, here velocity of the temperature here, of that temperature, the temperature is, we have Vt is equal to that's what they be 792 meter per second, and then the other one, the velocity at 0 is what we are looking for, because we need to get it before we'll be able to solve the wavelength. So the temperature at this one is what? 40 plus, that will give us, that is Kelvin. In Kelvin, remember, is square root. The square root, this has to be converted to what? Kelvin. And the next one, we're looking for the temperature. And this one is what? 0 plus. That will give us Kelvin. So then using this, knowing all these things now, we can substitute. You can substitute it here. So in this case, we will have, for this temperature, velocity, we have 792 over V0 equal to square root of 313 all over 273 all over 273. So the next thing that we have here is, if we divide them, we divide this, we will have by dividing we have 792 over 0 V0. That will give us all over 1.1465 approximately. So let's clean this end. Then we go ahead. Then we have if we square this one, if we get the square root of that, we have 79V equal to 1.07076 all over 1. So in this case, we can now cross over. If we cross over, we will have 1.07076V0 equal to 792. Then V0 will then be 792 over 1.07076. So I'm going to clean this thing. So what we divide it, what we have here should be, V, this cancelling out each other, we have our V0 to be equal to 739.7 meter per second. Approximately we have it to be, approximately should be 7 to the nearest whole number. We have it 740 meter per second. So this is our velocity. So in this case now, we have the velocity. We have the velocity we are looking for. The next thing we are going to do here is that we're going to find the wavelength. The wavelength, since the velocity is what? Velocity at this is 740 meter per second. The frequency remain the same, because the frequency there is what? We have it to be 660 Hertz. So in that case now, to get the wavelength of this, we know that velocity is this. Then to get the wavelength will then be velocity over what? Velocity over frequency. So what we have here is 740 all over 660. So what we do this thing, perhaps we can as well, if we divide it, we'll have, what we have as our answer here will be equal to 1.12 meter, 1.12 meter. That's the wavelength we are asked to find. 1.12 meter.